Welcome to another GC Basic demonstration for the PIC18xxQ24 chip families using the reset button. Yeah, it's like a Q24. We're going to use the reset button to do two functions, and it's worth noting this because it introduces another concept to microcontrollers and how that's implemented within GC Basic. So please like and subscribe, and let the video work all the way through. Thank you. So reset switch, and then once we've done that, we're going to pull together all 6 of the first videos into one super one at number 7. So, but we're using the reset switch in this demonstration. So I'm assuming you've got everything operational, and you have 2 switches connected now at the bottom bullet. You had one before, you've got 2. Now you might have had a pull-up resistor or something on this particular port.bit or this bit before this little input, but I need you to put a switch on it, okay? And I'll show you how to do that. Because we're going to have a switch connected to what's called port RE3. And this RE3 has a configuration switch. So we're going to look at how we change the configuration during the programming cycle of RE3 because it has 2 functions. It's also called the MCRLE, which is master clear, and you can have it as an external master clear, and when you push that, it's a reset. It resets the chip, which is quite useful if you just need to reset the chip. Or another way of doing it is power cycling it, but this is a reset. So, but that's controlled by the configuration. Or you can have it as internal, and then it becomes a port, an input port, just like similar to the rest. It can only be an input, but it gives you an additional port. Again, configuration changes how this operates. So how's it connected? Well, it's on this particular chip, it's up the top left-hand corner, RE3, MCRL. It's also called VPP, but we're just using the master clear part, and I've got a switch attached to that. And as per the diagram, it's attached via a 1K, and then it's pulled high with a 10K resistor. And so when I push that, it grounds it. And when it grounds it, it will either reset it or take the line low on a signal. So it's 2 things. Quite clever. What does that look like in terms of our little diagram? Well, two changes in here that you should be seeing. We'll bring the pen up. One, this word says switches, fancy that. And down here, I've added in port E. Port E, I'm so sorry. Port E3 has got a switch attached to it, just so that you've got this documented, and you'll see that reflected in the demonstration software. So, first of all, we're going to have it as an input. Depending how I've actually set the code, of course, it might be part 2 first, but we'll see. RA, no. Let me, RA, you can see that I reuse these slides a lot, huh? Yeah, that should be RE, and that should be RE. Where else have I not changed it? We'll see. So, RE is an input. The chip will be initialized, and then we're going to check this reset switch, and if it's been pushed, we'll toggle it in an LED, just so we can see it happening. But as part of the initialization, I am going to flash some other LEDs so we can always see when the chip is restarted. So it's going to flash it 20 times. And it will always do that. But then it will do the input check. And then in part 2, we'll change the configuration. We'll initialize it and we'll just see it reset because it's no longer an input. It's just a reset. So initialize flashing LED, do it forever. And if the button is depressed, it should set the LED if it's an input. If it's a reset, it will never set it. So what we're going to do is we're going to review we're going to go into the IDE, we're going to look at PICINFO, because there's a lot more configuration in there you can play with and look at some code and review the results. So let's go into the IDE. There we go. That's where we left it last time. Let's have a look on the old desk cam. This is where we left it last time. If I push this button here, we get our LEDs toggling. Now, up here on my board, it says the word reset. So if I just flip the camera around, can I do this live? That's going to be interesting, isn't it? Let me just see if I can do it live. Transform. There we go. Down here, look, it's down here now. It's not, hasn't changed from here, of course. Here, it says the word reset. And so if I push the reset, nothing happens. Where's the LEDs? You can see the LEDs. Nothing's happening because the reset is set as up an input. And so this switch here, which is wired up to the microcontroller, is doing nothing. But in a minute, it will be doing something. We'll see that. So that's the reset button we're going to be pushing. Me. Right. Let's get rid of the old one. Open up the Explorer. I use Control B. You can use any method you like. 080 using reset switch. Okay, using the reset switch as an input. And here is the code. It looks fantastic when it looks like that. Didn't expect it to open like that, but I'll zoom in for you. So what we've got, look, is a program. But look, it's got this standard start. We've seen this lots of times so far. Hash chip defines the chip, and we could change the frequency at the end of that. And we'll look at that in another demo. Option explicit, define all our constants. Then it's got hash config, MCLRE, internal master clear. Or it has two options. And you have to be the world's expert on this, do you? No, you don't, because if you press function key F4, type in PIC, and there's something called PICINFO. And PICINFO allows you to change the configuration. It says I've already got it running, which is true. I can see it down here, and here is PICINFO. Let me see if I can zoom in a bit better for you. There we go, PICINFO. So in PICINFO, if I type in the part, there's a lot of parts in here. I've already pre-selected it, but what you can do, you can just type it in the bottom, 18F26Q24, and it will then list it at the top, okay? It just pre-selects it for you. We've looked at this in the past, I believe. But this window here is what we're looking at now, these configuration options. And you've got a couple of buttons in here you can do. You can reset the config, and this is the default configuration that GC Basic uses. So that means that anything with a little star on it, it's the default. So we look at the default for this master clear by cursoring there. It's automatically defaulted to internal master clear. So it's an input. Now, I can take a copy of the whole of that configuration by pressing copy config, and it puts it in the cut and paste buffer. If I go back into my source program, I can take this line here and just Control V, and it will paste in the default configuration for us. You might want to change it, and this is how you change it. You could go to the data sheet to do the same, but PICINFO is a bit faster. So it says here, the internal master clear, that's what we want it to be set to. We'll come back to PICINFO shortly. Let's look at our program. Here's our documentation. You can see I've added in port E as per the diagram in PowerPoint. Always good to it. And I've actually added in a constant called a reset button on port E. Now, the reset button is set to an input, but it's set automatically because you can't set it as an output. It's set automatically. So let me just get rid of that little bit of documentation and those constants. And here's the main program. Main program says flash an LED 0 20 times. Every time it starts this chip, LED 0 is going to flash 20 times. That's quite important because in our brains, then we can see it flash every time it resets. Then, if I push the reset button, that means it goes to 0, and the LED 1's going to come off, or it will turn it off, on or off. That is the program. It is quite a simple program, but when we change the configuration, we are going to get a different operational mode. So let's go to Zen mode and program it. So I'll just put the program there in its entirety, press function key F5, or I am actually selecting today the top right hand icon, which has got M and H and F on it, make hex and flash. And when I do that correctly, it will then make the hex and flash. It's assembling it, it's created the hex file already, and as fast as I can describe it, it's programmed it. And notice the red LED is flashing. Let me prove it to you first. Look, unplug, plug in, the red LED flashes 10 times because the other 10 times is actually off. Okay, so if I push the reset button, the green, it's the yellow LED, looks like green to me on the screen. It's working, so it's doing exactly what I expected because the configuration is set to have this as an input, an internal master clear. Okay, so it's set to the input. If I change that to the, if I change the configuration, then you'll see the difference. I'm just cursoring up in the program so we can actually see it. Let me just change the position of the program. Here we go, put it there. If I change that to external master clear, I could just come into PICINFO actually, and I could, to be honest, it might be better just to bring it into here. If I just move that to the right a little bit. Copy that configuration, delete my configuration in here, Control V, I will get a different operation because this has changed. Compile that program. I moved it out of the way, that was my mistake. So I've compiled the program. You've seen it. It's now just flashed the LED 20 times. Now when I push the reset, it resets the chip. We changed the configuration. What other configuration changes can you make? Well, if we look at PICINFO, you can have a detailed look at what it can change. Bring it into view. I'm going to try and remember these things. Let's look at the big ones. This is code protection. This is EEPROM protection, on or off. Debug, yeah, you shouldn't use that. Shouldn't use that. If you don't know what you're doing, don't use it. If you want to use have the clock output on a particular port, you have to check data sheet, you would say on. If you wanted to have it so that you only change the PPS once, you'd set that to on. Bad practice, by the way, to do that. If you wanted to use, I'll talk about the memories later on. SAF is a type of memory and you wanted to lock it, you would say on or off in here, okay? I'll talk about that later. If you wanted to protect various zones of the memory, you would use these switches here. And if you wanted to protect zero crossing, you would change these here. So everything is, then you can go hunting around in the data sheet to figure out what all these mean. But all the options in there are also shown in the options tab, and here they all are in a big long list. So you can see that you can code protect things, and you can then work through and figure out what the particular parameters are. But we've already pre-selected the defaults in GC Basic to make it easier for you, so that we've pre-selected the configuration of the oscillator, etc. If we look back and I press reset, the defaults are clock out is disabled, there's no code protection, FCMO, I can't remember what that one is, the external oscillators turned off, low voltage programming is turned off, master clear is set to internal, no advanced interrupt handling, WTE and all the others are all set off. Those are the defaults. So you don't need to set them. All those are set by default. Hence, this program in the previous program didn't reset. Okay. There we go. It's really very simple to use. Very simple to use the configuration to change the chip. I will put that back as it was for the documentation, but as we've seen in the demo, that when I push the reset, it does its funky stuff. So I will put that back to internal, go back to Zen mode, we'll see it. It's just compiling. It will flash 10 times on and off. I press the reset button. The only reason I got my other finger on here, by the way, is so it doesn't move, because it's on the camera. Oh, it's flipped around the other way now. That's interesting. There we go. We're back to the internal switch. Fantastic. Configuration explained. Go and enjoy that. Where are we going next? Let's have a look what we've got in the PowerPoint. Right, we're going to pull the whole thing together. Switch ADC, make the LEDs flash in a sequence with a reverse because we can use the switch. And essentially, what the first 7 demonstrations are, they're the first demonstrations that microchips always used on what was called the low pin count board. And they slowly build up from an input and output to this configuration. It's quite intelligently building upon, so this isn't a great big program to start with, we're building upon. And then after that, we'll get a little bit more into the protocols. So enjoy.